setting foot on Mars has been one of the greatest discoveries in human history. Of course, no human has ever set foot on the red planet yet, but thanks to the robotic vehicles sent to explore Mars more closely, we are obtaining significant information. The most important of these discoveries date back to 2021. At this time, the Perseverance rover and the Ingenuity helicopter landed on Mars' red soil for the first time and began their adventures on Mars. Perseverance is studying geological structures, climate, and other environmental conditions on the surface and is also looking for signs of past life. This complex mission has various objectives, from searching for evidence of ancient microbial life on Mars to determining the geological history of Mars, and even paving the way for future human missions. The Ingenuity helicopter was designed to test whether flight in the Martian atmosphere is possible or not. Flying in the Martian atmosphere, which is much thinner than Earth's, brings many technical challenges. However, Ingenuity overcame these challenges and made history by successfully flying in the Martian atmosphere. These two vehicles represent NASA's latest technological advancements in the search for signs of life on Mars. The planet has never been looked at in such detail before. Each photograph and collected data sheds more light on the mysterious world of Mars, and perhaps most importantly, these missions help us in our search for answers to the question of whether life exists or has existed on Mars. An important part of NASA's Mars exploration program is also the InSight spacecraft. InSight was designed to delve into and study the depths and internal structure of the red planet. Based on the data it has sent in recent years, a series of earthquakes were detected on Mars for the first time. These earthquakes are occurring more frequently and stronger than we thought, some ranging between 3.0 and 4.0 on the Richter scale. This shows that Mars' crust is active and releases its energy through earthquakes. In 2019, InSight recorded more than 450 seismic events on Mars. One of these earthquakes occurred on May 22, 2019, an event measured as 3.7, was the largest earthquake ever recorded on Mars and provided important information about the planet's internal structure. On the one hand, these earthquakes have the potential to awaken dormant Martian volcanoes. It is believed that these volcanoes shaped the surface of Mars in the past and possibly triggered a warm and wet period. This past volcanic activity could have helped bring water and other vital elements to the surface and perhaps created conditions that could have once harbored life on Mars. One of the most striking examples is Olympus Mons, the largest volcano on Mars, and indeed the entire solar system. This giant volcano, with its height of 22 kilometers and a width of 600 kilometers, is almost 3 times larger than the largest volcano on Earth, Mauna Loa. Recent scientific research suggests that Olympus Mons is still dormant and a Martian earthquake could reactivate it. Another potential dormant volcano is Albertholus, located in the Tharsis region, which means martyrs in Arabic. This volcano is believed to have last erupted about 30 million years ago, which is relatively short compared to the planet's 4.6 billion year history. A series of powerful earthquakes could wake Albertholus and possibly cause an eruption. These possibilities once again demonstrate the importance of seismic examination of the depths and internal structure of Mars. Predicting when these sleeping giants might wake up could be crucial in understanding both past life forms and potential future life conditions. However, most importantly, these seismic activities provide clues about the presence and distribution of water and other basic life elements on the planet. The presence and distribution of water on Mars can be determined by following the traces of these seismic movements. It is also thought that these earthquakes could reveal potential underground water reservoirs forming beneath the crust of Mars. One of the most concrete pieces of evidence for traces of life on Mars is the topic of methane gas. The presence of methane gas on Mars excites scientists and increases the likelihood of life because methane on Earth is particularly produced as a result of biological processes. So, how and where does the methane gas on Mars come from? Measurements made by NASA's Mars exploration vehicle, Curiosity, in 2013 and 2014 revealed the presence of methane gas in the Mars atmosphere. However, the presence of methane does not necessarily mean that there is life. Methane can also be produced as a result of geological processes. Therefore, determining what the source of methane on Mars is of great importance to scientists. The amount of methane gas found on Mars varies seasonally. This methane could potentially be the result of biological processes, but it could also vary seasonally due to geological processes. While its source is not yet definitively determined, this discovery gives us hope that there might have been microbial life on the red planet in the past. The detection of organic molecules on Mars by NASA's Curiosity rover points to the existence of life's chemical foundations, including essential elements like carbon and hydrogen. These organic molecules were found in a 3 billion-year-old lake bed in Gale Crater, and could have played an important role in life's formation. However, determining how and when these molecules formed is challenging. The presence of these molecules suggests Mars could have hosted life in the past, but it doesn't definitively prove the existence of life. Instead, it shows Mars had the necessary chemical ingredients for life. The detection of seasonal flows of briny water on the Martian surface provides ambiguous clues to the potential existence of life. These recurring slope lineae, or RSLs, are considered a potential sign of life. The high-resolution imaging science experiment of NASA's Mars Reconnaissance Orbiter detected dark streaks on Mars' surface and slopes, which form when the surface is warmed and disappear during colder periods. These RSLs could be places where underground liquid water seeps to the surface and evaporates, but the water would have to be salty, as Mars' low atmospheric pressure causes pure water to rapidly evaporate and freeze. These salty water flows hint at the possibility of microbial life on Mars, as some microorganisms on Earth can live in environments with limited salty water. However, more scientific data is needed to determine exactly what these RSLs are. Deep beneath the Martian surface lies another potential habitat for life: underground lakes. The discovery of a large subglacial lake under 1.5 kilometers of ice at Mars' South Pole, based on data collected by the European Space Agency's Mars Express orbiter, is another potential habitat for life. Because liquid water is a vital requirement for all known life forms, this water could have supported life on or beneath the Martian surface at some point. However, considering Mars' low temperatures and thin atmosphere, the water in this lake would need to be mixed with salt or possibly other components to stay in liquid form under normal conditions. Earth has microorganisms that survive in extremely salty environments, so the salty water on Mars could provide a habitat for similar life forms. However, it remains to be determined whether this salty water meets the necessary salinity levels to support life. That is, does the salt concentration exceed the minimum water quality required for life? This is still an unknown. In short, we need more information about the nature and chemical composition of this underground water. The discovery of these lakes boosts hopes for the possibility of life on Mars. The mysterious lakes found beneath Mars' surface could potentially harbor life forms similar to those found in Earth's deep seas. However, Mars' surface itself also contains strong hints of past water, which are best illustrated by the ancient riverbeds found on Mars. NASA's Mars rovers have discovered stone beds and pebbles that show clear signs of past flowing water, especially in Gale Crater, which has been examined by the Curiosity rover since its 2012 landing. Riverbed-like formations, pebbles, and rocks eroded by water indicate that this region was once filled with water and possibly provided conditions suitable to support microbial life. However, the duration of this water's existence and whether that time span was sufficient for the development of life remain uncertain. Despite these unanswered questions, the riverbeds on Mars' surface clearly indicate that the planet had water and potentially life-supporting conditions in its past. In summary, the existence of water traces in Mars' ancient riverbeds suggests there was an environment capable of supporting life on the planet in the past. The Gale Crater and Mount Sharp offer further clues, holding significant information about past climate changes on Mars, potentially offering the most insightful location in understanding the habitability potential of the red planet. Gale Crater, once water-filled, hosts Mount Sharp, and the data collected by rovers indicate that the crater repeatedly filled and emptied, possibly due to climate changes. Mount Sharp rises in the middle of Gale Crater, and its layers allow us to read Mars' geological and climatic history. These layers bear the traces of a series of climate changes, suggesting Mars experienced a series of different climatic conditions over time and may have been able to support microbial life. With the information obtained from the crater and Sar Mountain, there is strong evidence that Mars' past climates could have been temperate enough to support life. However, to understand Mars' habitable past, we are turning to another region, Jezero Crater. This ancient lake bed is a region that gives us hope in our search for evidence of life on Mars. Jezero Crater, believed to have once been a lake, is an ancient delta that probably remained underwater. NASA has sent Perseverance for the Mars 2020 mission, because this environment contains minerals and geological formations that are likely to preserve potential traces of life. Jezero Crater, which was an ancient lake bed, might have supported water-based life forms in the past. Scientists hope that the samples collected by Perseverance in Jezero might contain biological markers that could prove life existed billions of years ago on Mars. In addition, the geological structure of Jezero can also provide information about Mars' ancient climate. Delta formations can help us understand the movement of water and how a lake that once existed formed and eventually dried up. Some specific minerals found on the surface of the red planet can be evidence of water, and perhaps life, especially a mineral called hematite found in various regions of Mars. Hematite is generally a mineral that indicates the presence of water, and the formations of hematite on Mars indicate that liquid water was once present and potentially hosted biological activity. Hematite on Mars is typically found in the form of spherical concretions or blueberries, which indicate the long-term presence of water beneath the planet's surface. Hematite beads found by NASA's Opportunity rover in 2004 in Meridiani on Mars are one of the most striking findings, suggesting that surface water once existed on Mars, creating an environment that could potentially support life. Hematite, as a mineral, not only implies the presence of water, but also carries hints of microbial life. On Earth, the hematite mineral sometimes forms as a result of microbial activity. This brings to mind the idea that hematite formations on Mars could have a biological source. As we continue to study traces of life in hematite, there is another mystery, yet to be fully resolved, found in the polar regions of the planet. As a result of possible global warming that could occur on Mars, the melting of the polar glaciers of the red planet and their conversion into water could increase the chances of life. The poles of the red planet host a large amount of water ice, which could create an environment where microbial life forms could exist. The polar glaciers on Mars show similarities to Earth's glaciers, but Mars' cold and thin atmosphere makes it difficult for water to remain in liquid form. However, it is thought that water can remain in liquid form under certain conditions, especially beneath the surface. Scientists know about microorganisms that live in extremely cold and frozen regions on Earth, i.e., our polar regions. These microorganisms could find a similar environment beneath the glaciers of Mars. In addition, the water found under the glaciers is a valuable source of information for understanding Mars' climate history. The potential signs of life and water sources found in the polar regions of Mars, which are the subject of research, not only reveal the possibility of life existing on Mars, but also its potential to spread from Mars to Earth or even to further points. The meteoroids found on Mars also raise interesting questions about interplanetary life transfer. The striking aspect of this issue is meteoroids that have fallen from Mars to Earth. These meteoroids on Mars show that life transfer from one planet to another is theoretically possible. This idea is known as the Panspermia Theory and proposes that simple life forms can survive for long periods in the vacuum of space. Consider that a rock fragment containing microbial life forms was ejected from the surface of Mars as a result of a collision, and this rock fragment fell to Earth. In this case, Martian bacteria could theoretically create a new form of life on Earth. Is this really possible? The answer is not yet certain, but certain evidence found in Mars meteoroids shows that this idea is not completely absurd. For example, the ALH 84001 meteorite, known to have come from Mars and found in Antarctica in 1984, contains shapes that could possibly carry traces of fossilized microbial life. This finding caused great debate in the scientific community, and no definitive conclusion has yet been reached. This possibility could greatly change our understanding of Mars' past and future. If we can find more concrete evidence of life on Mars, it could not only show that interplanetary life transfer is not just a theoretical possibility, but also a real past event. And maybe we are the distant descendants of microbes that originated from Mars' past life and started anew on Earth. Even this thought alone shows that we need to think more about our origins and the vastness of the universe. Thus, we have come to the end of our search for traces of life on Mars. To learn more about these topics and stay informed about the latest discoveries, you can subscribe to our channel. Remember, science never ends, and every new discovery is an opportunity to learn more about the universe. See you later.